This is the Bambu Lab A1, this is the Prusa MK4S, and this is the Sovol SV06 ACE, all blazing fast 3D printers, and in this video I'll be putting these three bed slingers up against each other to find out which one is worth your hard-earned money. So, let's get started. How's it going, guys? Angus here from Maker's Muse, where it's my aim to empower your creativity through technology, and we've got a classic 3D printer shootout on our hands. These three 3D printers are known as i3 style or bed slingers due to their XYZ configuration, which has the print bed moving forwards and back and the gantry moving up in the Z axis as the print is completed. This configuration is compact and cost effective and has been popular for well over 10 years now. But these 3D printers are nothing like the dodgy, unreliable i3s that came before them. The latest batch of bed slingers are rapid, running high-end motherboards with automatic features which makes 3D printing more accessible than ever before. So if you've been burnt in the past because you couldn't level your print bed or suffered constant nozzle jams due to poorly designed hot ends, then I encourage you to check out just how far these affordable 3D printers have come. I'll be assessing all three machines on their setup, ease of use, connectivity, and openness, along with the same batch of test 3D prints as suggested by the wonderful members of the Maker's Muse community, which you should totally join, links below. So we'll kick things off with the OG, Prusa Research with the latest and greatest Prusa MK4S. Joseph Prusa is largely responsible for why bed slingers took off in the first place, with his improvements on existing open source RepRap designs culminating in the Prusa Iteration 3 or Prusa i3. The Prusa MK4 dropped in March 2023, a full 6 years after the release of its predecessor, the Mark III, which was revolutionary back in 2017, but that's a long time to go between updates, although there were steady improvements over that time. To me, the Mark IV release felt rushed, and in my opinion, it was released before it was truly ready. However, there's been a ton of improvements to the Mark IV platform, and with the Mark IV-S, I now feel that this machine is worthy of review. I unboxed it on stream, and the process was ridiculously easy. This is the assembled unit, and it arrives basically ready to go in a huge, sturdy box. You get it out, clip some shipping ties off and attach the spool holder, and you're good to go for a first run wizard, which tests the machine and walks you through everything you need to know. This includes wireless connectivity if you choose to use it, and also there is a brand new app. But thankfully, it's not mandatory. The Mark IV-S has a print volume of 250 by 210 by 220mm in the Z, and is available fully assembled for $1,099 US, plus shipping and taxes. Yeah, more on that at the end. For the first test on the Mark IV-S, I ran the ludicrous benchy demo file using the included roll of filament. You get a whole spool. In fact, the Mark IV-S was the only printer in this lineup to include a full spool of filament in the box, which made quality testing a heck of a lot easier, so that's a big plus. Connectivity options include the USB or wireless through either Prusa Link or Prusa Connect, but knowing which one to use can be a little bit confusing. If you want your machine to be truly air-gapped, then you can use the USB stick to transfer G-code. If you want to print wirelessly on your local network, then you can add the printer's IP into Prusa Slicer with a randomly generated password. Or if you want to control your printer from anywhere, then you can use Prusa Connect, which uses their cloud printing service and ties into their app. So a lot of options depending on your preferences. It should be no surprise that Prusa Slicer comes with extensive profiles for the Mark IV-S, which are well tested if a little conservative. The Mark IV-S runs at a much higher pace than its predecessors, helped in part by the giant cooling fan hanging off the front of the hot end, but print times were in general a little bit slower than the other printers in this lineup. The quality, however, was very impressive. The clearance castle printed flawlessly with one of the best looking drawbridges I've ever seen, and the detail of the print was incredibly crisp. To test print quality and accuracy, I used the Autodesk Evaluation Test Print, which was originally developed to test Kickstarter printers, and it also was printed quite well, with all the clearance dowels falling away straight away, and the dimensional accuracy of the cylinders being fairly close to the model. Each was only about 0.1mm under the correct diameter. Where it didn't perform so well, however, were in the bridged areas, which drooped quite a lot and even failed entirely under the spires, which, as you can see, are incredibly stringy. This was a real surprise considering the pedigree of this printer, and I thought that it might be the generic PLA Plus I was using to test all the machines, so I tried the spires again using the provided roll of Prusa PLA, and got the same result. In fact, it might even be a little bit worse. Despite this, the Mark IV-S was able to complete the lattice cube test, which is an absolutely diabolical combination of thin details and steep overhangs. It's got that wispy stringiness to it, but it did actually complete, which is more than can be said for all the other printers in this lineup. When it comes to printing batches of parts, the Mark IV-S was nice and reliable, with even the smallest gear sticking well to the PEI spring steel plate, which is a PEI film, not powder coated, which is kind of interesting, though you can buy and use either on this machine. At the default 0.2mm layer height speed setting, this batch of parts completed in 2 hours and 39 minutes. Flexible performance on the Mark IV-S was also really impressive thanks to the planetary driven extruder gear, which imparts a lot of control and force on the filament as it's fed through the hot end. I was able to print this quite soft Polymaker 90A Shore Hardness TPU with no problems, although it's stuck mega hard to the print bed, which is my fault. I used to be religious about protecting PEI sheets with glue stick when printing TPU, but in the latest batches of powder-coated PEI beds, you don't seem to need to. This sheet, however, definitely does need it, so keep that in mind. Now, onto the ecosystem. Prusa printers are open source. It says it right there on the sales page. But if you're expecting a full CAD assembly of this machine to use as a reference to model your own parts, then you'll be disappointed. The firmware source is available, as are the electronic schematics, but the printer parts are only available in STL file format only, with DXF files available for the older Mark III gantry, but not the new die-cast gantry used in the Mark IV and Mark IV-S. The STL files are nice and they give you the opportunity to print spare parts, but they're not easy to modify, and I feel that that's by design. The Bambu Lab A1 is a rapid 3D printer from industry disruptor Bambu Lab. I'm going to call them that because the hobby 3D printing market was completely stagnant until they released the Bambu X1 Carbon onto the scene about 2 years ago. The A1 comes in a dense, compact box and it's well packed with lots of goodies inside. It does require some assembly. You bolt the gantry into place using screws and attach a few wires, and the instruction manual is small, but it has everything you need to assemble the machine. Everything is clearly marked, so you know what to do, and the whole process to assemble the printer takes 10 to 15 minutes max. Bambu Lab shipped me the A1 combo, which includes their multi-material unit, the AMS Lite, but for sake of this comparison, I won't be including it in the test prints. I recommend my review of the A1 Mini if you're interested in learning more about how the AMS Lite system works. Despite coming with a full multi-material system, however, this printer only shipped with a tiny sample of PLA, so make sure you buy some spools at the same time as the machine. Once you have the printer assembled, first run will walk you through the setup, which includes a full printer test and calibration routine and setup over Wi-Fi. And to complete this step, you'll need to use the Bambu Handy app. This machine does have a microSD card if you want to use it offline for loading of prints, as well as LAN mode to keep it on the local network, but the encouragement of using their app is fairly heavy-handed. The A1 has an impressive print volume of 256 by 256 by 256 in the Z, and without the AMS Lite, it actually comes in at US $339 plus shipping and taxes. The demo speed benching on the A1 was attempted using the provided sample of PLA, so naturally it tangled up and jammed. But what was impressive was the fact the printer detected this jam, it paused and it waited for me to clear it before continuing, and actually ended up printing a really decent result. The clearance castle, just like the Mark IV-S result, was superb. Everything moves as it should, with the drawbridge lowering, the tower unscrewing, and the portcullis being able to be raised smoothly. I'm starting to think I might need to redesign this file to make it harder. The Autodesk evaluation print was also quite impressive. There's a little bit of stringing on the spires, but nothing like the result of the Mark IV-S, and the bridging underneath them is cleaner as well. All the clearance dowels fell away straight away once the print was removed, and once again, actual measurements were maybe 0.1 millimeters or so undersize, which is very good dimensional accuracy of an FDM 3D printer. I find the surface finish changing from matte to a gloss finish on the print also particularly interesting, as that finish is related to how fast the printer is pumping out filament. The more matte the finish, the faster the extrusion was laid down. Unfortunately, the A1's rapid approach was its downfall when attempting the lattice cube, which is incredibly delicate and easy to snap if the nozzle collides with the print as it's printing. I'm sure if I slowed things down and I was a bit more careful, it could succeed, but I'm only testing default settings here, so keep this in mind if you intend to print super delicate models on this machine. Printing the full bed of gearbox parts revealed the true speed of this platform, with the entire batch completing in 2 hours and 20 minutes, and the parts look fantastic. There's a tiny bit of wispy stringing, but nothing too serious, and again you can see that matte finish because they were printed so fast. I've already had great success printing flexibles on the A1 Mini, so it wasn't much of a surprise to find out that the A1 is similarly very capable, with the very soft Polymaker 90A Shore Hardness TPU looking very good with no signs of under extrusion. The Bambu Lab A1, however, is completely and utterly locked down, closed source, and heavily reliant on the cloud for its functionality. Considering that the machine works so well out of the box, this isn't something that affects the usability of the machine, but if you're the kind of person who likes to tinker and modify their 3D printer, then you'll be very disappointed here. Bambu Lab also go one step further than most when it comes to the proprietary nature of their products, such as incorporating RFID tags into their own spools, which makes setting them up in the slicer a breeze, but it's only one firmware change away from potentially locking out anyone else's. Sending through the slicer when it's not in LAN mode also means your model information is being transmitted to their servers and back to your local network, so keep that in mind. Sovol only came onto my radar a few years ago with the Sovol SV06, an affordable alternative to the Prusa MK4S at the time, but it was pretty slow and wasn't very smart. It was, however, a solid starting point, and people have been upgrading those machines with Clipper and community-generated mods for some time, so it's great to see Sovol rising to the challenge and releasing the SV06 ACE, which brings the platform very much up to pace with the rest of the industry. The SV06 ACE arrived in the smallest box and needed the most assembly, but it really wasn't too bad. The instructions are a little bit unpolished and difficult to understand at times, but you slot the gantry into place, securing it with 4 large bolts before attaching the plugs to the motors and snapping a few things in place. Something that's very easy to miss, and I missed it the first time, are these 2 foam blocks wedged under the print bed, so make sure you remove those or you won't be able to home the printer. Also, once again, this machine didn't ship with any spools of filament, it just has a sample of white PLA, which doesn't look the highest quality. The first start runs you through a basic wizard with a simple but effective UI, and connectivity is via USB at the back, or you can connect to Wi-Fi and access the printer through its local IP address within Orca Slicer. The SV06 ACE has a print volume of 220 by 220 by 250mm in the Z and a price point of US $299 plus shipping and taxes. The SV06 ACE I was sent is pre-production, so it only had 2 demo models on the USB drive, but the Speed Benchy, which was run off using the sample white PLA, completed without issue. It's a little bit interesting to see they had the brim enabled, as keeping models stuck to this powder-coated print bed did actually prove to be a little bit challenging. The Autodesk evaluation print looks pretty dang good until you realize it actually layer shifted. This happened because the dowels broke free during the print, causing a nozzle collision and layer shifting the rest of the model. The print still managed to complete though, and all of those dowels did fall away, which means that the print precision is really high. It's just that bed adhesion isn't that great, which is weird because the first layer distance looks pretty spot on. Like the other printers in this roundup, the accuracy of the print also looks pretty good as well, with a very similar 0.1mm smaller diameter result than the model on the vertical cylinders. But what was most surprising with this print was the almost flawless result of the spires with only a tiny amount of wispy stringing between 2 of them. This is exactly the same PLA Plus I've used across the board on a 0.2mm layer default. I have since dropped this and broken it, but trust me, it was the best of the lot. Overhangs were okay, but they were actually the worst of the lineup, and that limited adhesion on the print bed really did sabotage the print. That poor adhesion to the print bed also unfortunately sabotaged the clearance castle. It looks incredible if you ignore the fact that the drawbridge did break free during the print, as did the tower spinning in place and ruining that part of the print. I was, however, able to run off the batch print of gears and components without any failures using the default 0.2mm profile in Orca Slicer, which was the only profile provided, and it finished at just around the 2-hour 10-minute mark, which is the fastest result among all 3 3D printers tested. Once again though, judging by the matte finish, I feel that the speed that's dialed into that profile is right at the edge of the hot end's capability, and I think it could actually benefit from being slowed down slightly, as it may start to suffer under extrusion when busting out larger prints if their hot end is starting to fail at keeping up. Flexible performance on the SV06 ACE was okay, but not the best. I got good results with Polymaker's high-flow 95A TPU, but unfortunately I got this really poor result from the softer 90A short hardness TPU. I had to make a profile from scratch to get it to work with a custom 3mm cubed per second max volumetric speed, so it was already going pretty slow and it might be able to be improved further with different retraction settings, but at least it didn't fully jam up the hot end, so I'll take that as a plus. The Sovol SV06 ACE is, believe it or not, completely open source, but getting to this point was a little bit complicated. Let me explain. When I first inquired, Sovol told me that because this printer runs a maker-based control board, they couldn't open source it, and I pushed back on that quite a bit. I told them that, like with the SV06, making this machine open source would be a very strong selling point because it's very well positioned at its price point for makers who also want the ability to upgrade, repair, and tinker on their 3D printers. And after a bit of internal discussion, I got back this message where I quote, "After the company inside discussion and push, we will open source all files the same as SV08 and finish uploading everything to GitHub before the 31st of October. I'll keep you updated once we upload." And I very much hope that is the case because it's awesome and I will definitely be following up on their claims. If you made it this far, then congratulations, you're well on your way to choosing the best 3D printer for your needs. But as always, it's never a clear-cut answer. Times have certainly changed. All of these machines figured out nozzle height and bed level on their own. I didn't have any prints catastrophically fail. And I found each of them to be pretty easy to set up, but the fully assembled Prusa MK4S was by far the easiest. If you were setting up a print farm, you'd literally just have to take them out of the box and plot them on a shelf and pretty much be done. It printed all of the test models well, other than annoying wispy stringing, which I'm yet to get to the bottom of, and Prusa Slicer, naturally, has tons of profiles built in, ready to go, and I like the ability of the MK4S to handle soft TPU, as that's quite handy for what I like to make. But, and it's a huge but, the MK4S is by far the most expensive printer I tested in this lineup, and it's by multiples of the other machines' price points. There's also many legacy details that just feel odd in this current market, like the persistence of 3D printed parts and a touchscreen with an encoder as well, which leaves you with a UI that makes you wonder which one to use. At $1,099 plus shipping and taxes, it is a very premium price for a bed slinger in 2024. You can buy the kit, but that is a very, very different experience and not something I'm going to be covering in this video. Moving on to the A1, however, this printer is a very different beast. It's easy to set up, rapid, fast, and has the intelligent features you need to get a newbie 3D printing. The print quality isn't better than the MK4S, but I find the workflow within Bambu Studio to be more seamless when you're going from design to print. It's also priced at $339 US currently, which makes it an absolute deal for the level of hassle-free printing it delivers. That's 3 of these with headroom for the price of one MK4S. The 3D printing industry sure has heated up over the last few years. You do, however, sell your soul a little if you go for the A1. Why? Well, it's closed source and cloud dependent. If your internet goes down, you can use this printer, but a lot of its features rely on that connection back to base. And some really weird stuff has happened on the Bambu Lab network before, like prints just starting on their own with network connected machines. I'm no security expert, but if you're 3D printing something you want to keep for yourself, then you might want to consider other options. And one final note with the A1, since when did flinging purged filament onto the floor become okay? We've got cats now, and they go for the PLA scraps like it's candy. So this flicking of sharp PLA turds is actually a pretty big issue, and I'm going to have to find a solution for it. And if you do go for the multi-material system, the AMS Lite, which is bundled with the A1 at US $489, then you'll have these little purges for every single color change. You can get incredible results out of that system, just be aware of how it works to achieve them. Last but certainly not least is the Sovol SV06 ACE. I quite like what Sovol is doing, a rapid bed slinger with features that compete with both the A1 and MK4S, but with an attractive price point of US $299 plus tax and shipping, with some refreshing design decisions. I reviewed the Sovol SV07, which was Sovol's prior fast i3 3D printer, but they failed to hit the mark with that machine, mostly because they used V-slot rollers. This printer, however, has absolutely huge hardened rods for Z, and it uses a U-channel roller system, which should be plenty rigid and durable for the much faster speeds this printer operates at. I actually really appreciate the fact they're just providing an Orca slicer profile instead of trying to hack up some custom slicer, and this is something that the community will definitely appreciate and build on as well. Same goes for making the assembly files available, which I am taking in good faith that they will do. It's a little rough around the edges and doesn't have the polish of the other two machines, but it is hard to argue with that price and the kind of ecosystem they're fostering with this printer. Purchase links can be found in the description below, and any questions, please leave them in a comment and I'll get back to as many as possible. All three machines were provided to me free of charge for purpose of review, and all thoughts are my own. Thanks for watching, guys. Bye.